Now let's consider an expression with a logarithm like this. And you've got to understand the interpretation of this. This means that the 8th root of 2. And in this particular case, without a base being written, you normally assume it's to the base 10. So what this really means is the logarithm of 2 to the power 1/8. That means the 8th root of 2. And one of your laws, if you have the log of x to any base to a power, you are allowed to bring the power down. So in this case we can bring this 8th down and in effect work out the logarithm of 2 and then divide it by 8. And if we do that, you get 0.038. Another expression is when you start off with the logarithm of a number of terms in which you have to express as one single log. Again, you just assume that you have the same base. It doesn't really matter what the base is here, but assume it's to the base 10. You can't really combine them until you get rid of these numbers in front of the log. So from your relationship of now taking the power back up, we now are subtracting 2 logarithms and then adding a logarithm. When you subtract 2 logarithms, you can say it's the logarithm of the division of the 2 numbers. So you can say it's the log of 2x divided by x squared. And because you're adding this logarithm, you can in effect multiply that part by 2 to the power x. So that's what you have. And here what you've got to realize is that some things do cancel. This is like x divided by x squared, which is like 3 divided by 3 squared. So one of these x's cancels out with one of those x's just to leave you an x on the bottom. Well, at the same time, these 2 numbers multiplied together have the same base, so you can add the indices. We know there's an index 1 there, but we don't normally write it. But your answer would be the log of 2 to the 1 plus x, or x plus 1 if you prefer. And then you're dividing all of that by x. And that's the expression you have.